when we're presented with a context, it's helpful to examine the units. So in number 1, if we have some kind of context where we're multiplying millions of students per year times the number of years, so maybe you're looking at like the enrollment at a college or the number of people doing something. You have millions of students per year times years. What happens is when you multiply the units, the years cancel out because that second one is like years over 1. So the years cancel out and you're left with million students as your unit. Okay, in part B, now I put some numbers with it. Suppose you have $3 million per year times 6 years. So for example, maybe the profit at a company is increasing by $3 million per year over the course of 6 years. What happened? Well, again, year cancels. 3 times 6 is 18, and then $1 million is all you're left with for the words. So $18 million. So try the last 3 there. Part C is a little tricky, but just pay attention to where the words are, and we'll see what happens. Okay, so when you look at in part C, just the numbers, we have 70 times 500,000, but then we have divided by 100,000 in the denominator. So what I would look at is 500,000 divided by 100,000, they reduce out to just 5. So then if you multiply 70 times 5, you get 350. And then what we're left with, residents cancel out. You're left with births per day. So 350 births per day. Okay, so try the last 2. Again, you can pause the video. And there's the answers for those. So in the last one, notice how hour cancels out, day cancels out. So 60 times 10 times 5 is 3,000, and you're left with miles. So that could be if you're traveling 60 miles per hour for 10 hours per day, and then you go for 5 days, you would travel 3,000 miles. Okay, so hopefully by looking at those, you can see that looking at the units or the words will help make sense of what how to interpret your answer. So moving on to number 2, I give you just kind of a stupid example here. The number of daily likes Susie gets on her social media posts are given by f of x, where x is the number of days since she began tracking the number of likes. So evaluate f of 0 and f of 20. So all you're going to do is substitute 0 into your function and then substitute 20 into the function. And you should always think about when you have a word problem, what is the 0 telling us? What is the 20 telling us? So the 0 is telling us that x is 0 in this case, which means 0 days since she began tracking. So that's like the start of when she started keeping track of her likes. 20 means that she's 20 days since she started tracking her likes. So just a straightforward, substitute those in. Okay, so I show the substitution of 0 and 20 into the function, and you get 60 and 180 for your answers. So then evaluate f of 20 minus f of 0 and explain its meaning. So we have our answers here, 180 minus 60, which gives us 120. So all that's saying is 20 days after starting, Susie had 120 more likes. So the number of likes increased by 120 over that 20-day span. Moving on. And I want to point out, you could look at this as absolute change. In part C, f of 20 minus f of 0 divided by 20 minus 0. So here, again, f of 20 and f of 0 we already have, 180 and 60, and then 20 minus 0 is 20. So when you do that calculation, notice what that gives us. it gives us 120 over 20, which is 6. The units on that, and this is why I want you to pay attention to units, the units on that are likes per day. So think about in the numerator, 100 with the 180 represented 180 likes, minus 60 likes gives you 120 likes. And then on the bottom, that 20 minus 0, that was the number of days that went by. So 6 likes per day, think about what that means, is your slope, or rate of change. So the number of likes increased by 6 likes per day. I have no idea if that's good or bad. Actually, I think the more likes you get, the worse it is. All right, but that's just me. Part D. Now evaluate f of 20 minus f of 0 divided by f of 0. So notice again, the f of 20 minus f of 0 is the same as in those first two questions. And then divided by f of 0. Well, f of 0, notice how that is the same thing as right here. So what that's finding for us is the relative change. So when you do that, 180 minus 60 over 60 gives you 2. Now there's a reason why I'm giving you that one where you get exactly 2. It's to pay attention to what we have as our units. This was likes on top, and then f of 0 was also 60 likes. So if you have likes over likes, they cancel out and there's no more units left. So what's happening here is this is your relative change. Remember when you had new minus old over old? These two numbers here match up. That's a relative change. So now think about, what does that 2 mean? Well, isn't that really 2.0? So as a percentage, you move the decimal 2 places to the right. And I would just say, think about if you had 0.32 for an answer there, wouldn't you say that is 32%? Well, now the decimal is just after the 2, but you still move it 2 places to the right. So that represents the number of likes increasing by 200% over those 20 days. And if you look at what happened with the number of likes, they went from 60 to 180, so they more than doubled. They went up by 200%. Okay, so 60, doubling it will be 120, and then another 60 would get you to the 180. So it increased by 200%. Okay, moving on to the next examples on the next page. The quadratic equation P of S represents the profit of a company when the selling price of their item is S dollars. So this is very similar to the last one. So what I would suggest you do is go through and try it, and then I'll put the answers up. Okay, so pause the video. So there's the first one. That's just evaluating, plugging 0 in and plugging 20 in. And remember that S, the number in the parentheses, represents the selling price of their item. So when they sell the item for $0, their profit is negative $12,000, which means they're losing $12,000. When they charge $20 for the item, their profit is $8,000. So now, if you evaluate P of 20 minus P of 0, think about that as absolute change. And over here, this one is going to be average rate of change, because you're dividing by y minus y over an x minus x. Okay, so that's going to be an average rate of change. So again, pause the video and do it, and I'm going to show the answer. So in the first one, 8,000 minus negative 12,000 is 20,000, which is just saying that their profit is $20,000 more when they increase the selling price of the item from $0 to $20. Part C, you end up with 1,000. We subtracted dollars on top and dollars on the bottom. Now that seems kind of weird, but the dollars on top represents their profit. The dollars on the bottom represents the selling price. So even though that's a weird looking unit, dollars per dollar, the profit increases by $1,000 because that was the numerator per, or for each dollar that they increase the selling price by. Now that's only on the interval from 0 to 20. So when the selling price increases from 0 to $20, their profit increases $1,000 for each dollar they increase that price by, the selling price. Okay, moving on to the next one. This one, I changed the numbers, P of 35 minus P of 50 over 35 minus 50. Again, notice how that is similar to this one here. You have the Y values on top, subtracting X values on the bottom. So now, when you do that one, you end up with negative $300 per dollar. So what that means is their profit decreases by $300 for each dollar they increase the selling price by, from $35 to $50. Now, if you're thinking, well, Marks, that makes no sense at all. You're saying up here, it increases by their profit increases by $1,000 for every dollar increase in the selling price, and down here they're losing $300 for each dollar increase. Well, notice those are on different intervals. And without getting into too much detail, the idea there is if S is the amount of dollars that they're selling the item for, when you sell it for $0, you're not bringing in any money. So they're losing $12,000. But as you start selling or increasing the selling price, what's going to happen is you're going to start taking in money. Well, eventually, you're going to get to a point where that selling price, once it gets too high, you're going to decrease the demand for that item. So you're going to sell, potentially you're going to sell less items. So that's what's happening here, is that once they get past a certain amount, so probably past $20 somewhere, at some point, the selling price is going to be so high, they're going to start to sell less of those items. So the profit is going to start decreasing again at some point. Basically, they're pricing themselves out of a market. And just to give you a stupid example of that, if I gave you, hey, there's a green pen, and I say, I'm going to charge $1,000 for anybody that wants to buy that pen, well, that pen might have cost me 30 cents to buy, and I want to sell it for $1 million. Well, I'm going to lose 30 cents because nobody's going to buy it. But if I said, okay, I'm going to charge 10 cents for the pen, or maybe 20 cents for the pen, or 30 cents for the pen, then people might become more interested in it. Eventually, I'm going to start charging too much for that pen, where the demand is going to drop down again. Okay, so that's what's happening here. So that's just kind of a silly example of what I'm talking about.